All right, everyone, take 20 seconds, 30 seconds to go through and do the unit quiz. All I'm looking for is, for delta X, what is the unit that goes with it? You can be just the letter, the abbreviation of the units, or write of the whole word. I don't really care. I'd probably go with the abbreviation. Okay? For these 6 things, I'll give you about 20 seconds to go through those. We'll talk about them briefly. All right, so delta X, what unit are we going to use to measure delta X?
Meters.
Meters. It could simply be the letter M, or you could write out the word meters. I don't really care. Acceleration.
Meters per second squared.
Per second squared. Time, or T for time. Seconds. Then final velocity.
Meters per second.
And initial velocity.
Meters per second.
And displacement in the y direction.
Meters.
Okay, so as long as you put units in with these, you're going to get these back out. And by identifying what it is, it's going to be helpful. So if you're reading a problem and you see 10m, oh, hey, that either has to be a displacement in the delta x or delta y. Or if you say, hey, something is at -2 meters per second squared, that must be my acceleration. That's why those units are helpful. Okay? So you picked up 5 sheets, that's one of them. The other 2 are progress quizzes, 4.2.2 and 2.6. Those are something that sometime during the day today you should do, and I have the answers posted here, as well as on today's Canvas agenda. I would encourage you to try it first without looking here or on the agenda. Try to solve it, because if you go through and you say, the acceleration, oh, what's the acceleration? Oh, now I know the acceleration is. I mean, my guess is you're going to miss that, okay? So you really want to try those. So those are 2 things for you to work on. The sheet called Goes Up, Goes Down is a homework sheet for virtual day tomorrow. That's not something for class today. So you get to it, you get to it. These are good to do, nothing to turn in, but I strongly encourage you to do it and get some questions answered that you may have. The last thing, I'm sure this is going to be the last thing that I want you to look at is we are going to do a lab activity today that deals with reaction time lab. Okay, so that was the last sheet. The last sheet was reaction time. So in this drawer is a whole pile of meter-6. You're going to need a partner for this one. And you're going to touch the same meter-6 that your partner touches. So the best solution that we found is each of you will take a vinyl glove. And hopefully you're all don't have a, and then the idea is only the glove hand matches. This is not going to work because I need 2 hands in a second. You only are going to use 1. Okay? So what's about to happen is what you and a partner would do together. And on that reaction time lab, you are going to calculate what your reaction time is. Okay? So there is a table in the procedure. Basically what you're going to do is you're going to rest your hand on the table. The key is rest your hand on the table. And then you will rest your hand here. Your partner will hold the meter stick. It's your partner's responsibility to hold your fingers at the 50 centimeter mark. You're going to rest your hand. Now if you don't, you can cheat. And we don't want you to cheat. Okay, so the idea is you're gonna rest your hand at 50 centimeters, and then your partner's gonna say, are you ready? And you say yes. And then whenever they feel like it, they're gonna drop it, and then you try to catch it. Okay, 5 centimeters, about 2 inches apart. You want your fingers about 2 inches apart. You're holding at the fending, 50 centimeters. And then they say, are you ready? And you say, yeah. Now, notice how I said, on your mark, like, I've seen this happen. Are you ready? Yeah, I'm ready. On your mark, get set, go. And then they drop it on it, and then it's more like just a timing thing, right? The intent is not a timing thing. The intent is a reaction. So the partner says, are you ready? And you'd be like, yeah, I'm ready. And then at some point, they're going to drop it, and then you try to catch it as quickly as you can. Now, I caught it, and I caught my fingers. I did it a little too fast. Okay, I caught it, and my fingers are at the 33 centimeter mark. I started at 50, and now I'm at 33. How far did my meter stick fall? 50 to 33. Well, if it went to 40, that would have been 10, but it kept going to 39, 38, 33, so 17 centimeters.
Hey, nice job, Owen.
Okay, it went 17 centimeters. Now, if I would have held it the other way, I would have started at 50, and I would have caught it at 67, which would have been 17 centimeters. Now, did this go up 17 centimeters or down 17 centimeters?
Pretty sure it went down.
So you should probably make sure you have a negative displacement. Now, all of our units, according to the unit quiz you just took, had to be in meters. So you don't want 17 centimeters, you want however many meters it is. Things to keep in mind, if I would have told you that you have 17 cents, you could probably very easily convert that into a decimal of a dollar. Exact same conversion to go from centimeters to meters. Centimeters, right? So it went down negative 1.7 meters. Then you do it again, and you say, are you ready? Yeah, I'm ready. And then they drop it, and I catch it. And this time I caught it at 63. So this time it went 23 centimeters. Down. Okay? Are you ready? Yeah, I'm ready. If you really want to get tricky, you can say, look, an eagle, and be like, what? And then you might want to redo that one. But it's always fun to laugh at your friend when it hits it. If it hits and bounces it, it doesn't count. Okay? So you're going to go through. Now, most people, now think about this. If I drop this 1,000, less than a second it took to hit the ground. So if you calculate your time to be more than a second, you probably screwed something up. So on this data table, the displacement is the thing you're going to measure. You're going to catch it 5 times. Catch it, catch it, catch it, catch it 5 times. Then you need to calculate Fab 5 list, go through your problem types. Is it 1D motion? Is it a free fall problem? Was it drop? Did we drop the meter stick? And we're calculating time. You only have to show me one sample calculation, because then from there you're just changing the displacement to come up with your 5 reaction times. That data table, what was your fastest time? What was the smallest number? What was your slowest? And then what was your average? Then there's 2 questions. The 2 questions are saying if you were to hold the meter stick at 50 centimeters and it were to get dropped and you catch it right at the very last second, right before it hits the ground. So it would have fallen either, you can decide 50 centimeters or 49 centimeters. I'd probably go with 50. What is the absolute slowest? Is a calculation time that you must have had in order to still catch it if it was 50 centimeters. That's what that question is. There's a question and then there's a spot for you to fill in your answer. The last question says, the total length of a dollar bill is 15.6 centimeters. If you were to hold your fingers in the middle, like on George Washington's face, what would your reaction time have to be to catch it? Okay, now that the total length is 15.6 centimeters. Remember, George is halfway through. Okay, so you're going to do it 5 times. You mark and set, go. And you mark, you ready? Yeah, I'm ready. Are you ready? Yeah, I'm ready. You ready? Yeah, I'm ready. I don't remember how many, I think there's 4. You ready? Yeah, I'm ready. Okay. Now you recorded all 5. Then you switch spots with your partner. The fact that you have a gloved hand on, you use that one, and then your partner has a gloved hand, they've touched this, no one is, in theory, has touched the meter stick. But when we're all done, we take some paper towel and we spray our paper towel, and then we use our paper towel to wipe off our meter stick, and then we throw it in the, that's pretty good. we throw it in the drawer, okay? I should have actually not done that, because now I don't remember which one it was. That was